today I'm introducing you our project, UAV image processing system for crop field management. This project is managed by Dr. Wang and Dr. Gong at NDSU. Our research purpose is to develop an embedded system which can be equipped on UAVs. Comparing with other UAV products, our product will focus on lowering memory usage, reduce power consumption, reduce the speed of data transmission, and also minimize the weight of UAVs.
The first step of this project, we just want to use a simple board to test the flow and algorithm. And so we are using the LAN type 2.0176A, which is the embedded system board for embedded system class. This is a simple board which has some basic function of embedded system board. It has a LCD screen and also has some UART, but it's enough for our first step, image processing. And we do get some sample photos and put on this board and get some initial result. I'll show you how to use this board to process in the basic image for our project. For this project, we're counting the population of this one. So this is the RGB image we shoot by my iPad. This is just a basic image outside. And we also use this guy. As you can see, this is the infrared image. This is my hand. And to show you how, we also took an infrared image of the same RGB image, and then we're gonna transfer it to our board. I'll show you the infrared image, which is this guy, this one. And then we're gonna, since our board doesn't have a camera, and we have to transfer it to a TST file, we are taking the RGB value, and then we're sending it by hyperterminal using UART. And this one, RGB flower, is our TST file. So it's sending the data right now, and it takes around 5 minutes to get the initial result.
Okay, now we have finished the thermal image processing, and if I press this button, you will see the result. Red area lower than 45 degrees, object number 7, temperature at the cursor point 45.3 degrees. And you might think this one is one flower, but it's actually two. You can see it from the computer's RGB image here. These two are kind of connected with each other, but our algorithm recognizes that and says it's 7 flowers. We're pretty happy with the result. So in this picture, we don't have any other useless information. Instead, we only have white, black, and red part. White means there is nothing important, and black part means there is an object we're going to count, and red part means the temperature is lower than 45 degrees, and that means something to the farmers. Comparing with the image we were using before, the thermal image and RGB image of the 7 flowers, this one saved a lot of memory and also saved a lot of power during the data transmission time. So as we mentioned before, the board we were using is kind of slow. It's not an image processing board, and we switched to this new one. This one has 2 CPUs. The highest speed can be 2.1 gigahertz, and it has GPU on board, and also so many USB connectors. Like this one is GPS. We'll apply the locations of the crops in the future. And this is a USB camera, and this is a LCD screen. We haven't connected it yet. And this one is a Wi-Fi module, so it can transmit the information in real time.
As we previously presented in this first part of video, we demoed this image processing method is durable. And for the next step, we plan to hook up the camera, GPS, and also the Wi-Fi module to the new board, which is master fast board, by the way, and integrated as a whole system. And after that, after we reach this goal, we're gonna design a new customized chip and a new PCB board and integrate a whole system. And for our new devices, I believe it's going to be very helpful for the farmers. And compared to the device they have on the market right now, our device have a lot of advantages. For example, we have saved a lot of memory space, which is almost like 20 times less than the device they have on the market. Also, we reduce a lot of power consumption, which is a big deal for the new devices. And we also, for our devices, it's really easy to use. We don't need any technicians. Any farmers could use this device very easily. And the speed of this system is really, really fast. We only take like few hours, even minutes to finish this image processing process. And it's almost like a real-time system. And we also reduce the weight of the UAVs since we only have like chips and PCBs, and so we can put on the UAVs very easily. And this is our new system.